Hello friends, in this video we will study stack data structure and its application. So before that we will study what do you mean by data structure. Data is nothing but the information and structure is nothing but a particular way of organizing the data in a computer so that it can be used efficiently. So we have different type of data structures like we have stacks, queues, arrays and linked list. In this session let us study stack data structure. So data structure can be mainly divided into two types. One is linear data structure and one is non-linear data structure. So your linear data structure can be again divided into arrays, queues and stacks, stack, linked list, etc. And your non-linear data structure contains your trees and graphs. So first we will study what is linear data structure. So linear data structure is nothing but a data is arranged in linear sequence. Data items can be traversed in a single run. In linear data structure what happens is elements are accessed or they are placed in a continuous memory locations. Okay. So next we will study what is stack. So stack is a special type of data structure wherein the last item inserted will be the first item to be removed out. So it is also called as last in first out data structure. So we can insert the element from only one end called top of the stack and the elements are deleted from the same end, that is from top of the stack. Examples of your stack are, that is you can see here we have a stack of books and we can have a stack of plates. Okay. And the operation that can be performed on stack are push and pop. Mainly these two operations can be performed on the stack. Push operation is also called as insert operation and pop operation is also called as delete operation. As you can see here only one end of the stack is open. From this end only we are performing push and pop operation. Okay. So push operation is used to insert the item into the stack and pop operation is used to delete the item from the stack. And top is a pointer, that is it represents the current location of the data in the stack. So here is an example of the stack. So we have three elements initially in the stack, that is A, B, C. If I want to push one more element D, then we can push that element on top of the C. If I want to push one more element E, then that will be pushed on the top of D. If I want to pop the element, that is if I want to delete an item, I can delete the topmost element of the stack, that is E get deleted. Then the remaining contents will be A, B, C, D. Then I want to perform one more pop operation, that is D get deleted, that is the content of the stack will remain A, B, C. Like this you can insert any number of elements into the stack and you can pop the elements from the stack from only one end, that is from top of the stack. So algorithm of insertion in a stack. Okay, how to push an element onto the stack. So I have three elements A, B, C. Okay, I want to push the element D onto the stack. So what I have to do? So before inserting any element into the stack, you have to check for the condition called as stack overflow. So what is stack overflow? If top equal to maximum size of your stack, then it leads to a stack overflow condition. So before inserting element, you have to check this condition. If top equal to max, then you have to print an appropriate error message called as stack overflow. Otherwise, first you have to increment top is equals to top plus 1. Then you have to insert the item into the top of the stack. So in this way I can insert the element D onto the top of the stack and your pointer or top get automatically incremented to D. So similarly you can perform the delete operation, that is delete is also called as pop operation. So before deleting the elements from the stack, you have to check one more condition called as stack underflow. That is if top equal to 0, it means that stack is empty. You cannot delete any elements from the stack. So before deleting element, you have to make sure that the elements are present in the stack. Otherwise, you have to print an appropriate message called as stack underflow. Okay. After checking this condition, what happens? Item, you are going to pop the topmost element of the stack. Now top is pointing to 15. So this element will get deleted and top will decrement by 1, that is top is equals to top minus 1. So now your top is pointing to 12. Again I will perform one more pop operation, then this 12 get deleted and top will be decremented to 10. Okay. Then I will delete 10 and your top will be decrementing by 1 and it will be pointing to 5. After deleting 5, your top will be top will be pointing to 0, then it means that it is an empty stack. Then it leads to a stack underflow condition. So you can display the content of the stack also. So before displaying the content of the stack, you have to check for the stack empty. If stack is empty, we cannot display the content of the stack. So if top is equals to 0, then print stack empty. Else take a for loop, that is I will be pointing to the top, okay, from I equal to top to 0. Okay, whatever elements are there, you have to print it. So use print a of I. So end for exit. So the elements get displayed as E, then S, then R, then E, V, E and R. So applications of stack. There are many applications of stack. So first one is reversing the strings. So to reverse a string, the character of the strings are pushed onto the stack one by one as the string is read from left to right. Once all the characters of the string are pushed onto the stack, they are popped one by one. Since the character last pushed will be the first to be removed out. So subsequent pop operation results in the reverse of the given string. So for example, here I have a string called as reverse, R-E-V-E-R-S-E. So I will push one by one character onto the stack, okay. Then I will apply the pop operation. Then you will get the elements as first is E, then S, then R, then E, then V, then E, then R. You will get the reverse of the string. So second application of your stack is checking the validity of an expression containing nested parentheses. So it is used to check whether the given expression contain nested parentheses is properly parenthesized or not. So the program for checking the validity of an expression verifies that for each left parenthesis or bracket there is a corresponding closing symbol and the symbols are appropriately nested. So example, so these are some valid inputs of your parenthesized expressions and these are the invalid inputs. So for every opening brace you should have a closing brace, otherwise it leads to an error. So your stack is used to check the validity of an expression. Okay, so third one application is evaluating arithmetic expressions. So you can easily evaluate arithmetic expression using stack. So you will be having three notations. One is infix notation, one is prefix and one is postfix. So infix is nothing but whenever an operator is placed in between two operands, it is called as infix expression. So a plus b will be an infix expression. Then prefix is nothing but the operator will be always placed first. Okay, then comes the operands plus ab. This is called as prefix notation. And postfix expression is nothing but ab plus. So we are going to convert this infix expression to either a postfix or prefix because it is easy for the evaluation. So how to convert your infix expression to postfix expression? So for this conversion we need to know the precedence of operators. Okay, always the highest precedence will be given for the brackets, that is parenthesis, and then next comes the multiplication operator, then plus and minus. So you have to evaluate it to postfix. That is, it will be as 4, 1, minus, okay, and then the plus, minus and star symbol is there, okay. Then you can convert this one, this will be 2, 4, minus, 3 star plus. So in this way you can convert any infix expression into a postfix expression. Then you can go for the evaluation of the postfix expression. So whenever an operand comes, you have to push it on top of the stack, and whenever an operator comes, you have to pop two operands and you have to perform the particular operation. So first is 2, okay, this will be pushed onto the top of the stack. Then comes 4, then comes 1, okay, then minus operator is there. Whenever operator comes, you have to pop two operands, 4 and 1 will be popped and that operation will be applied. 4 minus 1 will be 3. That result will be again pushed onto the top of the stack. So the content of the stack will be 2 and 3, okay. So the next item is 3. So you have to push that onto the top of the stack. So the stack content will be 2, 3, 3. So next is star is there. So whenever operator comes, you have to pop two elements of the stack. So 9 and 2 will be popped, and 3 and 3 will be popped, and the result will be 9. That result will be again pushed onto the top of the stack. So again you have a plus operator here. Again pop two elements, 2 and 9. So 9 plus 2 will be 11. So 11 will be pushed onto the top of the stack. So this is the result of your postfix expression.